Hello everybody. I hope you're fine. So, just gonna continue this paper, Mathematics Paper 1, November 2024. Now, now you're gonna be checking patterns now. So the statement says the first term, as it is now shown here that I wrote, that is T1 there. It's given. It is 7. So now you can just record that now T1 equals to 7 or A equals to 7. Okay. Then now the common difference of this series, it is what? 5. The common difference is basically that value of D, which is 5. We must write down the data that they are giving you. I'm happy that now this question is not a headache, whatever, because now they are giving you all the values that you are going to utilize. Then the series contains 20 terms. Can you see 20 terms? So it means that now how many terms do you have? 20. So these are the number of terms that you have. The first question, calculate the sum of this series. When they say sum, those two formulas must come into your mind. But now, as you can see, I can see that now I cannot utilize the other one because now I do not have the last term. So now, as you can see, T1 equals to 7, D equals to 5, N equals to 20. Just gonna use the data I have. Now, since they want the sum of this series, just gonna use that formula. Sn equals to n over 2, 2a plus n minus 1 times d. Can you see that I wrote times d here? Because many of you make a mistake by saying n minus 1 and then write the d. This is not mathematically correct. Then now when you're done now, you substitute. Where there is n, you put what? 20, because now I have 20 terms. And since they want the sum of this series, I have to do what? To find the sum of the first 20 series, the sum of the 20 terms. Because now, if maybe they said find the sum of the 10 terms, I was going to write as 10. But since they said that now calculate the sum of this series, they mean the whole thing. 20 over 2, 2 times a, which is what? 7, plus n, which is what? 20 minus 1, 19. Times what? 5. Then now what do you get now from all this? The answer that you'll get is going to be 1090. Okay, so this is the answer for the sum of this series. I like this question, 2.1.2. The original arithmetic series is extended to what? 75. The original arithmetic series is extended to what? To 75. Okay, 75 times. What does it mean? It doesn't mean that now they changed this number of terms from 20 to what you call to 75. No, it has been extended. Do you get what I'm trying to tell you? Meaning that now they're gonna start from this point up to that one, and then now the sum of this 75 times, it is just equals to 14,400. Okay, using sigma notation, let me go through this thing with you. Using sigma notation, write down an equation for the sum of terms added to the original terms. Now they want what? The sum of terms that are added to the original series. So basically, they want us to find, remember that we have the sum of the terms that has been extended and the sum of the original series. Now where are we gonna start? There is somewhere that you're gonna start. The first thing first, we know that now the sum of the first 20 terms of the original arithmetic sequence is what? 1090, right? We got it now. Now we also know that now the sum of the 75 terms, it is what? 14,400. How are we gonna get the sum of the terms added to the original terms? We are simply gonna say now S75 minus S20. This is how you're gonna get the sum of the terms that are added in between. What are we gonna get now? We are just gonna get what? 14,400 minus 1090, which will give us what? 13,310. So these are the sum of terms that are added. Do you get what I'm trying to say? Now let's continue. Now we have to do, now we are not done. They said they want the equation in what? Sigma notation. So you know that now sigma notation is something that looks like this, right? Whereby this is start, this is end, right? whereby now this is what Tn. Now, what is going on here is that we have to determine our starting point and our ending point. The first thing first that I can say is that we already know our ending point. You know that now we end at what? 75 times. But are we starting at n equals to 20 or n equals to 21? We are obviously going to start at what? N equals to 21, because now we already knew that now the first terms of the original arithmetic series, it is what? 20. So basically there are 20 terms of the original arithmetic series. Now we also have the what? The terms that are what? Extended after the one of the original. So now that's why I'm saying we're gonna start on 21. N equals to 21. But now since things are like that, I just have to do what? To find the what you call the nth term or the formula there. How am I gonna find it? Now this is what I'm gonna do. Remember, I just have my data there. So now you know that now Tn equals to A plus n minus 1 times D. Remember, I'm still using the data I was given there initially. So Tn will be just equals to 7 plus n minus 1 times 5, which gives me 5n minus 5 plus 7, 2. This is the Tn I have. Now I can now do my sigma notation. And I also have the what? The sum of terms that are added to the original thing. Now I'm gonna write 5n plus 2 here. Where is it starting? N equals to 21. Do you get what I'm trying to tell you there? Then now, where is it ending? At 75. Can you see it? Now, equals to. This equals to means that now the sum of this, it is equals to this value. But you got it to what? 1310 there. To 13,310. I hope you understood the question. Okay. Now we are just going to continue on the second question, which is 2.2 now. Then now, what does it say now? The sequence of the first difference of a quadratic pattern is what? 1, 3, 5. And as you can see, it means that now it is continuing because I have these dots there. Can you see what I'm talking about? If T, I'm recording the data, right? If T99 is 9,632, calculate T98. But be careful. Are we calculating T98 of the quadratic pattern or T98 of the first difference? What are we calculating now? What are we calculating? We are basically calculating what? The T98 or the 98th term of the quadratic pattern. Okay? But now, how are you going to do that? We start now. Remember, I have recorded my data there. Now, let's start. Basically, this is what I have. 1, 3, 5 are the first differences of the quadratic pattern, right? But now there's something I want to tell you guys. You know that now the first difference of the quadratic pattern, it is basically what? Your arithmetic pattern. That's what you know. So basically it means that now this 1, 3, 5 thing, it is basically a what? Arithmetic pattern. Now I want to show you something. Since they want T98 of the quadratic pattern given T99 of the quadratic pattern, you can play with the mathematics there. First thing first, let's find our nth term of this first difference thing. A plus n minus 1 times D. So 1, 3, 5, 2, 2. So my D is equals to 2 sharp. Now what is the first term? 1. What is my difference? 2. So basically the nth term, it is 2n, and then 2n minus 2 plus 1, it is what? Minus 1. This is the nth term of the first difference now. But now check something. Check something. T99 of the quadratic equation, it is 9,632, right? But now check something. They want us to calculate the value of T98. Now this is something like this. 99 98, 99, right? Then now what's happening there? This is whereby now you have what? T99 minus T98. Okay, so basically what is happening now, it is that now I am gonna calculate the 98th term of the arithmetic sequence. Do you know why I'm trying to do that? Because I want to find T98 of the quadratic pattern. So basically with this 135 blah 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 blah, I want to calculate what? The 98th term. So basically T98 will be equals to 2 times 98 minus 1, which is basically equals to 98 times 98. What is it? 98 times 98 minus 1. I'm gonna get 195. Yes, 195. Okay. Now, let's continue now. What do we have now? What else are we supposed to calculate now? Now, since we have that data, we are gonna continue and find the value of the thing now. T98. Now, let's go back to the diagram I showed you right now, the one that I just showed you. Remember, let me say quad for quadratic. For quadratic, I basically have 98, 99, right? Now, what happens now? 98 minus 99, 99 minus 98, what must it give me? It must give me what? The answer there. But now the answer that it will give me will be 195 there. Do you get what I'm trying to say? Why am I saying 195? Because I just calculated the what? The 98th term of the arithmetic pattern. So since I have this 195, what am I going to do now? I'm just going to say T99 minus T98, it is going to be equals to 195. I hope you understand this whole thing because it is very, very important. Okay? It is very, very important. Because now you know that now the thing, the T1, T2, T3, blah, 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 T4, then now T2 minus T1, it is this one, this place there. T3 minus T4 minus T3, it is this value that you have there. Can you see why I'm also saying that T99 minus T98, it is 195? Then now you got it now. Then now, T99, it is what I'm looking for, right? What is it? T98. But my T99, it is what? 9,632 minus T98. It is the one I'm looking for. This basically means that now T98, it is equals to 9632 minus 195, which will give me what? 9437. Okay? I hope you got the answer there. Now, going on to the last question. It is further given that now the third term of the quadratic pattern is 32. Determine the general term. Haha, mathematics. Now, they gave me the value of what? They gave me the third term of the quadratic. So basically for the quadratic, what do I have? I have x because it's unknown. I have y. But now the third term, it is what? 32. What am I going to do? I know, please do not make a mistake and put y minus x, because we are given the pattern of the first difference to be what? 135. So now I have 1, 3. The next one must be 5. So maybe here I can say z. Okay? Now, we know that now the common difference there, it is just 2, 2. You know how we find the equation of a quadratic. 2a equals to 2. A equals to 1, right? 3a plus b equals to 1. Because I'm using these values, you know, right? Now, it means that now 3 plus b equals to 1. Therefore, b equals to minus 2. You know that now a plus b plus c must be equals to t1. So far, t1, it is x. It's unknown. Interesting, eh? But now, I have my a as 1. I have my b as what? Minus 2. But I do not have my c. I do not have my t1. What can I do as a mathematician? I know in my quadratic sequence that now I have T98, I have T99. Since you also want to be safe, use the answer that they gave you. Use the value they gave you because you have the value of T99, T98. So now, to be safe, let's use the value of what? T99. So now what is it going to happen? I basically have Tn equals to A is 1, so n squared minus 2n plus c. Get what I'm trying to say? Tn, now it is going to be T99 equals to 99 squared minus 2 times 99 plus c. What is my T99? 9632 equals to 99 squared minus 99 times 2 plus c. Therefore, it means that now the value of c will be equals to 9632 minus 99 squared plus 99 times 2. Because I'm taking everything to the left hand side, which means that now my c it is equals to 29. To conclude that mathematically, Tn it is equals to n squared minus 2n plus 29. That's how you manipulate your what? Your questions now in what? Mathematics. Do you get what I'm trying to tell you now? That's how it is, guys. I hope you understand the gist of this question. Okay? We'll meet on the other question. Thank you.